Hello, everyone. My name is Clemens Jütte, and I'm a platform architect at Humanitec. Today, we're going to have a little conversation about cost control, the art of ensuring lean resource allocation, optimally and securely reuse running instances, tearing them down or restarting them on a schedule. So to do that, we're going to have a look at Humanitec. Let me go right away to my browser and the UI of the Platform Orchestrator. So let's have a look. You can see I'm only running two applications in this demo instance, and I'm going to the resource management now. Here I'm just running a set of demo instances as well, but I hope they are enough to illustrate everything I want to talk about. So this is basically a single pane of glass and a consistent API to identify idle and old resources. And also, as you can see, as there are not many resources in here, they nevertheless can run an arbitrarily high amount of applications, and by that, foster standardization. Standardization will obviously not only reduce resource sprawl, but can also be used to counter cost-creating anti-patterns. If you're able to work on those standardized resource patterns, then obviously you can identify things that cost you, remediate them, and then make your applications deploy on a new iteration of those resources, and by that counter those cost anti-patterns. But let's have a look how this UI and also the underlying UI and CLI can help you to identify um, resources which are probably a little bit old. So first of all, we're going to look at this Kubernetes cluster here named RefArch. And you can see on this screen that there are two applications actually running. The both I'm running in this instance are running on this cluster. And if I open this, I get a little bit more information about this. Then I can go off to the application and I can find out that in the development environment, the last deployment was on the 18th of October around noon. Well, that is nice, but essentially it's also a little bit of clicking around that we probably don't want to do. So let's have a look at how the CLI and the API can actually help me to do this a little bit better. Over to the terminal. I have a few things here, and the one I'm going to show you first is the resdevs sh. And inside there of this little shell script is this call, which is using humctl, our own CLI tool, which is named in memoriam of kubectl, to execute an API call, so I don't have to care for the authentication against the Platform Orchestrator's API. The tool will handle that for me. So I'm doing a get on this endpoint, which is basically going to show me all of the resource definitions. And then on top of that, RefArch, so our Kubernetes cluster, and all of the resources which are actually running on top of that Kubernetes cluster, or all of the instances of resources which are based on this resource definition. And for your convenience, so I don't hit you in the face with a lot of YAML, which carries along a lot more information, I'm going to pipe this into YAML query and actually focus just on the application ID. So you get the same information as a quick glance on this page would actually provide you. So let's actually execute this. And you can see immediately HTTP 200, this call went through well, and I can see that my Backstage application and my JTest 101 application are both in the list because they are actually running on top of this cluster. So that was an API call. Let's have a look what else we can do with that. And for that, I have the htest sh. Not agenda, htest.sh. So this one is a little bit longer and more elaborate. But let's have a look what's in here. So first of all, I'm getting all of the applications and I'm using once again humctl for that. and I'm cutting down to the ID of them. And then I'm using xargs to actually execute for each application ID another command. In this case, I'm echoing this out, so I actually do not lose the application ID. And then I'm calling out to humctl once again to get all of the environments, which are now dependent on the Humanitec org I'm currently in, and also on the ID I'm passing in. That is actually filtering down to the object, and inside of there, just giving me the name and the last deploy created at. So, which definitely gives me the same information than clicking around in the UI as you've seen, but in a much more convenient way. Let's execute this here. That will quickly not only give me Backstage and JTest 101, the two that you've seen already in the first call, but also tell me that their development environment has been deployed last time on the 18th of October this year at around noon. Well, this is interesting, but in this case, it doesn't help identify a lot because I'm just running these demo instances here. So let me quickly hop over to another tenant where I do have a little bit more data. Kind of a Humanitec preview organization. And let me execute the same script call here. Now you can see that, for example, my test2 application was actually deployed the last time in February. Either this is the most stable test application ever, or probably I'm just wasting resources here and need to talk to the owner to be able to find out if I can decommission this. And also I can see there are a lot of environments here, like this special environment, which actually was never deployed ever. So most probably I'm just wasting resources here again. Okay. I hope that this little demonstration did give you a good idea how quickly and easily you can take this to actually find out what is running where and what you should be doing with it. Of course, you can use all of that and integrate it in fully into your automation. Anything you've seen me use the CLI tooling for is available as an API call, so you can actually integrate that into your own tooling as well without further hassle. Right, thinking about this, you've seen me observe the system. But essentially, I can not only observe the system, I can actually manipulate it as well using the same methodology. Because inside of the resource management, I define resources. And I can also define very special resources which allow me to work with the system. Let's find out what I do mean with this. I also have this little thing here called label thing.yaml. And what it will do if I apply-f, so if I apply this configuration against the orchestrator, you'll see here, I'm going to create a resource definition, and it's going to be of name label thing, and it's going to be of type workload. And now I can use the matching system. I'm currently defining no criteria here, so I'm matching it to everything to say, okay, please match to everything. And now, as soon as something is matched by this and deployed, it actually uses this snippet here, which is in JSON patch notation and using Go templating to actually update the spec of the element in question and add the Datadog labels here. So, and by just adding those labels, I have activated observability for the workload. Let's see if this is actually something that holds true. Okay, so first of all, quickly reload to resource management so you can see the label thing is in here now. Currently, I'm not, I haven't deployed, I'm not seeing the changes this is provoking. So let's do a kube control get on the pods, which are inside of my JTest 101 development workspace. And there's just one pod in here. Let's do a kube control describe of that. Almost of the pod I have in here in my command history. One development. And if I go up here, I can find the labels. And inside here, you will see there are no labels which are of concern to Datadog. Okay, so let's go here inside of this and do another deploy. And to facilitate that, I'm going to go in here and just review and deploy it. And let's call this redeploy with Datadog labels. Great. That is going to take just a moment to actually redeploy the thing because there's not a lot of change happening here. Up and running it is. So let me get the pods again because the name should have actually changed. So control describe pod change name in the namespace jtest101 dash development. Wow. Development. Where's the typo? Ha, I can see it. Here's the typo. So you see no smoke and mirrors in here. I'm using this live and I'm not cutting out my errors. Okay, and if I go up here again, I can see in the label section now, the Datadog labels have actually been added. So it is nice to actually be able to activate observability, but why the hell am I doing this in a talk where I talk about cost? Well, if you think about systems which are usually there for forecasting, for cost control, things like this, they very much depend on your ability to actually create a taxonomy which captures how all of the things that you run on top of your Kubernetes clusters and also at the sides of Kubernetes clusters are actually being or where they are actually being coming from. So what does that mean? If I am inside of department A, most probably I want to have some labels affixed to my workload and also some identifiers affixed to all of the things which are provisioned beside the workload, like a database, which is not running inside of the Kubernetes cluster. So I enable my cost control solution to be able to identify everything which is belonging to department A, and by that enable forecasting for a confined group or a confined cost center, and also enable chargeback because who should get the invoice, right? If you don't know what is belonging where. So the most problematic thing usually is developing this taxonomy and defining a rule set that is able to react almost in real time and attribute all of the workloads and the other resources towards the billing targets. By using the orchestrator, as you have seen, it is really easy to define those rules and from the sidelines, without anyone needing to know or notice, inject those labels freely and as needed. Obviously, you can also label things inside of cloud provider APIs, or you could also, in our system, demarcate resources with the matching annotations. So you're able at any time to identify them and promote them towards your cloud costing solution, which enables this easily. So, and generally, this whole thing makes the pain in this area disappear and equips your platform engineering team with unparalleled flexibility to roll out such solutions. Right. And as soon as you have identified, like I did in the last step, those things which are not really worthwhile to keep alive, obviously you can sunset them easily through the API, consistently and reliably. So let me show you another thing. Currently, I have deployed the thing here, but this is actually accruing costs. I, as a developer, am probably very busy during the day, but very at sleep during the night. If you want to reduce your cost footprint, let's say during the sleeping hours of your developers, you can probably make good use of this button up here. If I push this button, I can pause the environment and by that reduce anything in there which is not holding state to zero quickly. So if I do the same query, once again, kube control get all of the pods inside of my development environment for this application. Now I have none anymore because they are not holding state, so they are reduced to zero. Let's say I wake up at 3 in the morning and have the absolute urge to write some code because I've had an epiphany in my sleep. Then I just go here and push the button, and within a few seconds, you can see that my pods are running again and I'm actually ready to write my code and deploy it for testing. Easy as pie. So let's see as a last thing how quickly you can go ahead and actually create a new environment from any kind of action. I'm using one of our reference architectures here as a starting point. So I also have it linked up to a GitHub organization and repository. And let me quickly go over there, HTC demo 29 into my JTest 101 application. And I have hooked that up using GitHub Actions to the system. That means if I go ahead and now do any kind of change here, let's say I go into my score YAML file, which describes all of the nice things that I want to have together with my application. And I go in here and I want to order a new database. I would just say MyDB of type MySQL. And I go ahead. I have to move this a little bit because I think I've hidden the button behind my video image. No, where is it? There it is. Commit the changes. And I go to my work self and I'm creating a new branch for this commit and I'm starting a pull request. And I'm creating that pull request. Now what happens in the background? Through the automation that GitHub Actions is providing me, it is calling out to the orchestrator's API and using the power of dynamic configuration management to actually stand up an ephemeral environment to test this pull request code while it is running, and it is going to roll it in automatically as soon as the pull request has been tested, is merged back and closed. And due to that, I'm able to very efficiently stand up new environments if I really need them and be able to scrap them as soon as I don't need them anymore. If you're currently living in a scenario where you have more than one development system because people step on each other's toes, or you have automated test sets that do not want to be interrupted by developers in any way, and because of that, you have more systems which are consistently running and accruing cost, this is something that could most probably give you relief in that area. So while this is running, let's have a quick look over at the orchestrator. I can already see that an environment called PR-1 has been created, and it is currently being deployed. The reason why this is taking a little bit of time is because in the background I have a full iteration that an image gets built, gets dropped into a registry, and the whole thing is deployed with all infrastructure being created. And if I go in here, I can see that my MySQL database has actually been provisioned. So going back here, I can now see, okay, the deployment with this ID has actually run well. I can see the score output if I fancy, and I see that this is the URL where my application is running, and it is running nicely. Okay, that looks good. I conclude that this pull request can be merged, so I confirm the merge. Pull request successfully merged and closed. And if I look back at the orchestrator, I will very soon see that this environment has actually been closed. Refresh this. Here we go. The environment is gone. And by that, obviously, the cost has evaporated as well. That would accrue if it would be still running. This concludes my whirlwind tour of the cost sector with just a few features that I quickly wanted to cover. This is by no means an extensive tour around the sector, neither in breadth nor in depth. So if you would like to explore this together with one of our platform architects, please reach out and you can book yourself into a demo and have a good conversation about the topic. And the next thing you could do could as well be take a look at the other capabilities of the Humanitec product suite, or as I said, reach out. I hope you had a good time viewing this as I had a good time presenting it, and I wish you a good day. Thank you for considering Humanitec. Bye bye.